Hi everyone, I just wanted to make a video on inverse trig functions because I know a lot of students find these difficult. So in this question here, we've been given the graph of y equals a half arctan of x, where arctan of x just means tan to the minus 1 of x. You might have seen that notation. And what do we want to do? We want to find the range of this function. We then want to find the inverse function. And we then want to find the gradient of the inverse at the origin, and then finally the gradient of the original at the origin. So to find the range of f of x, I think it's useful just to have a quick think about tan of x. So the graph of tan of x, we know it has two asymptotes, and it goes off like this. So this is tan of x. Now, where are these asymptote lines? So it happens at plus and minus pi by 2. So the domain of tan of x is minus pi by 2 up to pi by 2. And the range of the function is all of r, every real number. So we need to think about how we flip from tan of x to inverse tan of x, and we know that the domain and range of inverse functions, they swap. So the range of f of x is going to be the domain of tan of x. Now we only consider this branch of the graph because we know we can get multiple roots, so we could have this pattern repeating off and multiples if we add on pi to each of these, but we only consider this bit. And the only other difference is that we have a half here, so we just need to divide. So our range for part 1, the range is going to be between minus pi by 4 less than y less than pi by 4. So this is the range of f of x. So we can sort of think of these asymptote lines as being at pi by 4 and minus pi by 4. Secondly, we want to find the inverse function. So how do we do inverse functions? If we let y equal a half arctan of x, then we want to make x the subject of this equation. So let's multiply through by 2. 2y equals arctan of x. So tan of 2y equals x, and this is just our f inverse. So f inverse of x equals tan of 2x. This is our inverse function. Now what do we want to do next? We want to find the gradient of this function at the origin. So we need to differentiate. So f inverse of x, and then I'm going to differentiate. So we need to apply the chain rule because we've got a 2x here. So we know the derivative of tan is sec squared, but because we've got a 2 here, that 2 comes out the front. So this is 2 times sec squared of x, which is just 2 divided by cos squared of x. And since we want to find the gradient at the origin, this is when x equals 0, we plug that in, and we get that f inverse of 0 dash, we get 2 divided by cos of 0 is 1, so cos squared of 0 is 1, so we just get 2. Now finally, we want to find the gradient of f of x at the origin, so our original function. And the result we can use for this is that the gradient of f of x is going to be 1 over the gradient of the inverse of f of x. So we can just write it down. We can say f dash of 0 equals 1 over 2, so a half. So this is how you'd answer this question with inverse functions and inverse trig.